In this example, I would like to show you how the workflow in GIS and how we extract the data that then we use for the hydrological model using TwinLab and the GIS software and packages that we decided to use. First of all, we have to load the packages, in this case Google Earth Engine and GRASS. So Google Earth Engine is a web-based tool. It needs to start a session online to be used. First of all, it needs an authentication, which means that we send a request to Google to start this session. I already did it here because it takes some time, so we just need to initialize the session. Now the session is started. The first step is to import the data that we need. So I import the data for all Norway and then from the catchment that we're going to analyze. For all Norway, and this is what we have. That's a map of the entire country divided in subcatchments. This map has some interactive features like zoom in, draw in some simple shapes, and here it has some tools like the inspector tool. We can take snapshots, we can save the map, we can load different maps, we can load different background maps, etc. Now we're going to focus on the catchment where we develop the hydrological model and the hydraulic model. We load the catchment. I'll show it to you. This is the Grunoi catchment. We will focus on this small catchment. The numbers are the sub-ID corresponding to every one of these catchments here as a sub-ID in Norway. But this is an hydropower regulated catchment. So we don't need this division of the catchments. We need a more detailed division, which is what we did. And now I'll show it to you. Instead of having 3 subcatchments, we have 6. And we will use this to extract the land cover data. While land cover are used for land cover data have many uses, and in hydrological models usually requires this kind of data as input data. Here we combine these features with the vast dataset of Google Earth Engine. So we load the land cover data that are already inside Google Earth Engine for 2019, and I'll show it to you. They are available for the whole world. There's a very detailed legend, different classes, etc. This is basically everything we need. It is 100 meter resolution. Now we need to clip this data for the catchment that we are going to use. And the result is that from that land cover map, we extract the land cover only for the Grunoi catchment. Now we have a map, but obviously for the hydrological model, we don't need this kind of data, or we don't need the data in this format better. So what we need is to do a spatial statistic on using these subcatchments. Now I run the command, I export the file, which is now ready for the hydrological model. And just to show you how it is, this is how the data are. So for each subcatchment, I have a land cover class, and I count how many pixels correspond to that land cover class, which means I have the area in the subcatchment of the land cover class. And this is what I need for the hydrological model. In this case, we already add the subcatchments, the feature that we needed. But this is not a very common case. Many times we just need to select our catchment. And wow, we can do it. As I told you before, this map has some limited but useful interactive features. So we can zoom in, select, using the inspector tool, select a random catchment. And here, now we know the sub-ID of that catchment. We can just copy it and paste it in this command line. And I run it. Now I extracted the data, the land cover data, only for that subcatchment. And use loading. Yes, these are the land data for that subcatchment. In hydrological analysis, we won't use often this kind of process because we need more than one subcatchment, or at least it has to have to be hydrologically consistent. We need usually the subcatchment upstream of a point. So if we know the sub-ID of the whole subcatchments, we can do that. Another way is to combine GRASS and Google Earth Engine to extract the subcatchment upstream of a point.